Let's do this example. We've got 502 and we've got a 4x4 matrix here that we want to take the determinant of. Now, the first thing you want to do when you're doing this is find whichever row or column has the most zeros in it. So in this case, it looks like, let's see, this column has 2 zeros and this column has, or this row has 2 zeros. So we definitely want to expand along one of those. And I don't think it much matters which one. Let's expand along the bottom row. So I'm going to highlight the bottom row and let's expand along that. So let's see, we're going to have 3 times something. Now, do we put a plus or a minus in front of this? Well, if we start over here, plus, minus, plus, minus. You know, it's a, think about that as a checkerboard, and it always starts with plus up here in the top corner. So that's what I'm doing when I say this, plus, minus, plus, minus. So we get minus 3. I'm going to cross this out, times the smaller determinant, 351,204,147. And then the next one is going to be plus 4. Now, the thing is, you can just alternate when you go from one to the next, or you can come back up here and say plus, minus, plus, minus, plus, and get the 4 there. And let's see, I'm going to cross this out. You get 251,104,047. All right, and now I've got to do these two smaller determinants. Let's see, 351,204,147. At least this one has some zeros in it. So we get 0 there. So let's see, for added numbers, we get 0 plus 20 plus 8. And for our subtracted numbers, we get 0. Let's see, we get minus 0, minus 4 times 4 is 16, times 3 is 48. And then 5 times 2 is 10, times 7 is 70. So this turns into 28 minus 48. Minus 70 is negative 90. All right, so for this other one, we get 0, 0, 4. And going on the back, we get 0, 32, and then minus 35. So 4 minus 32 minus 35 gives me negative 63. All right, so that's like scratch work, sort of. And so I come back and my answer is going to be negative 3 times negative 90 plus 4 times negative 63. Let's see, negative 3 times negative 90 minus 4 times 63 gives me 18. All right, so the determinant there is 18. All right, so one thing that's kind of obvious by now is cofactor expansion is in general very inefficient. If you don't have a bunch of zeros in your matrix, this is going to take you a long time. If you know about the complexity of algorithms, the complexity of this thing is O of n factorial. So if you took something like a 100 by 100 matrix and you tried to use this technique to find its determinant, it's the kind of thing that a supercomputer couldn't do, because it would take more time than there is in since the Big Bang. So there are more efficient ways of doing this, but they're more complicated. And we'll talk about those later in section 3.2. But for now, just keep in mind, this is very inefficient. And cofactor expansion is what we're going to use for bigger matrices.